Hello everyone, my name is Ren. In this video I'll be showing you how to implement sliders for your Roblox game. So I have this settings menu here with a frame and a scrolling frame and a UI list layout, and I want to implement sliders for my settings menu. I want it so that the player is able to open and close the settings menu and adjust the in-game music to their liking with a volume slider. So I currently don't have a slider on me right now, so we're gonna go ahead and create one. We're gonna insert a frame into our scrolling frame here. We're gonna call this setting container. We're gonna set its anchor point to its center, 0.5, 0.5. Set its size to 1 on the scale. And then set its background transparency to 1. Actually, no, we're going to set this to 0.2 and make this 0. Then we're going to have another UI list layout here and have it fill the horizontal direction and have its vertical alignment in the center. And then we're going to insert a text label here, call this setting name. We're going to make this anchor point at the leftmost side of this frame, so 0, 0, 5. And then we're gonna make this invisible, make this bolded, make this text color white, make this 42, and call this music. Then we're gonna adjust its size on the X by making it 100. I'm going to adjust the setting container real quick. Instead of making 100, I'm going to make it 75. I'm going to have another frame here instead of our setting container. We're going to call this slider container. We're going to make this centered 1, and then 1. We're going to add a UI flex item. What this does is that it's going to override the UI list layouts flex property and have it only apply to the specific instance that is parented to. So we're gonna add one last item here. We're gonna call it slider percentage. We're gonna set its flex mode to grow. And then I think we set this to no. We set this, okay. We set the size of our slider container on the X to 0. And then set its anchor point of this to be right here. So we're gonna take 1 on the X and halfway on the Y, so 1.05. I think that's about right. Yes. We're gonna make this invisible, make this bolded, make this white. We're gonna make this the same size as our setting name, or maybe slightly smaller. And then we're gonna make this maybe 100. Also, one last thing, we're gonna add some padding here and have a padding of 8 of all sides. maybe 4. I think 8 is a bit too much. We're then gonna make this invisible, our slider container, and then we're gonna actually make the slider itself. So we're gonna call this slider bar 0.5, 0.5, 1, 10, maybe 8. And then we're gonna have another frame here called a slider fill. This is where we're gonna see when we're dragging a slider the fill color. We're gonna set its anchor point to its leftmost side so that any subsequent changes to its position and size will be relative to its leftmost side here. So it's gonna be 0, 0, 5. Make this size on the y-axis 1. Make this centered. And then we're gonna make this about halfway. Then we're gonna give this a good sign color, like 50, 150, 255. And then we're gonna get a text button called the slider knob. We're gonna set its text transparency to 0. Make this a darker color than its background fill. Make this centered. Make this 10, 25. 1030. Looks good. Looks good. It doesn't have to be a rectangle. If you wanted to have like a little circle, then you would simply do it like this. You'll give this a UI corner, set this to 1, then you will have a circular knob, which I think I'll be doing it for this example. I'll also going to pad this of our slider bar here. It's too close to this. So here I'll be going to its size and add -24 to its offset to pad it by -24 on its x-axis. Which I think is nice. Okay, so we have our slider bar. The next thing is we have to implement some functionality to it. So how are we going to go about implementing the functionality for a slider? Well, first of all, we have to capture the inputs of the player clicking on a slider knob and dragging it around. Next, we have to get the position of the player's input. In our case, it's going to be the player's cursor, and get its position on the x-axis. After that, we have to find the leftmost side and the rightmost side of our slider bar. And then afterwards, you have to find how far or its relative position of the player's cursor on its x-axis is in between our leftmost side and our rightmost side of our slider. This should give us a normalized value, meaning a value between 0 and 1. So for example, if I have my cursor here in the middle when I'm dragging my slider, it should print out 0.5. If I have it here at the very left, it should print out 0. If I have it here at the very right, it should print out 1. Afterwards, we would want to map it into a custom min and max range for our slider. The reason why we're mapping it to a new range is so that this is going to be the range that we're going to update whatever setting we want to update. So for example, my in-game music here, right? I want it so that the player can adjust the player's the in-game music between a range of 0 and 1, because right now the min-max volumes for Roblox when they're handling sounds is 0 and 10, and I think that's a bit too much. So I wanted to change this range to 0 and 1. Lastly, I would want to update this slider percentage here. This will tell us, I guess, how much of our slider of our music is actually like, like our value, right? Your music is currently at 100% or 50%. So let's get to coding this. I'll be inserting a local script. First, we have to get what's called user input service. We're going to be using this service to capture player input, as well as knowing when the player is dragging their cursor around after selecting, after clicking and holding and dragging our slider knob. And then I'll initialize some variables here. So I'll say setting container equals script.parent, slider container equals setting container slider container, slider percentage equals setting container slider percentage. I want to move this up here, and then here I'll say slider bar equals slider container slider bar, slider fill is equal to slider bar, slider fill, slider knob is equal to slider bar, slider knob. And then we're gonna have two functions: mouse button 1 down, mouse button 1 up. Then we're gonna connect some events from our slider knob to these functions. We're gonna say mouse button 1 down, connect mouse button 1 down, mouse button 1 up, connect mouse button 1 down, and then user input service input ended, connect mouse button 1 up. So this is how we're going to capture the input of our player when they're clicking the slider knob. The reason why I have two events connected to the same function is because mouse button 1 up only fires when your cursor is on the slider knob itself. And the way we're going to address that caveat is going to have input ended connect to mouse button 1 up. But since input ended fires for every single time the player stops interacting with its input or device, we want it so that when the player ends their input, it should only be when they're dragging. So if I'll have a function variable here called isDragging, and then when the player initially clicks down on their slider knob, we will want to check if they're already dragging, right? So if the player is not already dragging, right, initially that should be the case. We're gonna say isDragging equals true. And then when the player releases their left mouse button, also the mouse button 1 refers to the player's left mouse button. If the player releases their left mouse button, we would want to check if they were already dragging, right? So if the player is already dragging when they release their left mouse button, then we can say that they're no longer dragging. Our next step is tracking when the player is moving their mouse around. So I have a second variable here called connection. And then I'm going to set this connection to I'm going to set this variable to a connection. User input service dot input change connect function input object. Input object is the instance that represents the player's input. So what we can do with this input object is get the player's position of his input. Since it's a vector 2, I'm pretty sure, the position of his input. So we can say input position is equal to input object dot position. So like it's a vector 3, sorry about that. And then we want to get only the x-axis of the player's input. Now when the player releases their left mouse button, we would want to disconnect this connection because the player is no longer dragging. It doesn't make sense for us to continue checking the player's cursor position when they're no longer dragging. So we're gonna disconnect it here. And just to test things a little, I'm going to print player is dragging input position not x, and then if we were to join the game, let me decrease the volume. If I were to join the game and click the slider knob here, what should happen is it should print player is dragging when I'm moving my mouse around. Would you look at that? Then if I were to release my left mouse button, it should no longer print that I am dragging. Nice. It's no longer printing because we've disconnected our connection. Nice. Next, we have to find our leftmost side and our rightmost side of our slider bar. To do that, we have to use this property called absolute position. Absolute position refers to the top left corner of this frame here. So if I were to pull up the docs here. Absolute position is a read-only property that provides a screen position of a GUI-based 2D element in pixels. Note that absolute position obviously represents the top left corner of a UI element. So, since it represents the top left corner, if we were to get only the X component of that position, we can say that the absolute position on its X component, X-axis, is our leftmost side. To get our rightmost side, we'd have to add our leftmost side to the frame's screen size of the player. And when I mean screen size, I mean how big is the frame on the player's end, on the player's screen. To do that, we'd have to use absolute size. And absolute size represents the player's... It describes the actual screen size of a GUI-based 2D element in pixels, which means it describes the screen size of a frame. It describes the size of a frame on the player's screen. That's what absolute size is. Let me actually pull up the docs right now. See, so look, absolute size is a read-only property that describes the actual screen size of a UI element in pixels. Sorry about that. To get our rightmost side, we'll just simply add on to our leftmost side from to rightmost side. Afterwards, we'd have to find the percentage points, right? How far does our cursor lie between our two boundaries here that we've found, our leftmost side and rightmost side. Where does our cursor lie in between those 2 points? And it should give us a percentage. So allow me to introduce you to inverse lerp. Now what inverse lerp does is that it gives you a normalized value percentage between 0 and 1. Sorry, where was I? I had to pause my recording. Something came up with. What inverse lerp does is it gives you a normalized value between 0 and 1, pretty much a percentage, the way I see it, between two numbers, a initial and a final, or just simply two numbers, right? So an example where you would use inverse lerp is a health bar, right? Let's say you have a variable called player health and it's set to 100, and then, or no, sorry, let's say you have the player's health and then you're making a health bar and you want to showcase to the player, hey, this is your current health, and you wanted to visually display that fill bar, right, that represents the player's HP, and you wanted to dynamically change its size on the x-axis accordingly to the player's HP. But what you would do is, you could simply divide your max HP by its current HP of the player, or what you could do is you could use this function, this inverse lerp. You could input the player's current health with its minimum health, which is 0, because that's when you die, and then its max health, which is, there's a property called humanoid.max health, I'm pretty sure. You just input that, and then this should give you a value between 0 and 1. What you can do with this value is that you can dynamically change the size of your fill frame of your health bar, and this is what we're gonna use to find what percent of the way does our cursor lie in between our 2 points here. So we're gonna say relative position is equal to inverse lerp input position on the x, our leftmost side and our rightmost side. Since the player can go beyond our slider, we want to clamp it only in between 0 and 1. So if we were to, we're going to be using math.clamp, and then we're going to clamp it in between 0 and 1. So if we were to test this, what should happen is right in the middle, it should print 0.5, just like so. And then if we go to the left, it should print 0. Go to the right, it should print 1. And since I'm beyond the boundaries of our slider, it's still printing 1. Nice. Now, in all honesty, I could just leave it like this. However, okay, I don't know why I said that line. Now, I want to have a custom min and max values for my slider as well as a increment. So we're gonna write some more variables here. Min value equals 0 and max value equals 1. then we're going to have an increment of 0.05. Now, the idea is we would want to map this relative position, which is between 0 and 1, to our new range of our min and max value. Okay, for the sake of this tutorial, I'll have it as 105, because later down the line, I'll be changing these values to update our music in Workspace. So we're going to be using this method called math.map to convert our relative position, its current range of 0 to 1, to a new range of our min and max value. But before that, we have to snap our position into a increment. So we're going to be using this function called snap to increment here. What it's going to do is that we're going to see how many times does a number go into increment, round it to its nearest 100, whole number, sorry, and then multiply it by its increment again. What this should do is whenever we drag our slider around, right, left to right, the values, when we map our relative position to our new range of 0 to 100, it should only increase by our given increment. So we're going to say snap position is equal to snap to increment math.map the relative position, our current range, and our new range. If we were to print this out, what should happen is instead of printing 0 and 1, it should print a number in our new range that increases and decreases by our increment. So here, it's printing 50, and if I were to go to the left, it's printing 0, and it all decreases and increases by an increment of 5. This is good. This is nice. Lastly, to change our slider knob and our slider fill, we would then have to do another inverse slurp operation, but this time we're going to be using a snap position and finding what percentage of the way does it lie in between our min and max value. So I'm going to call this slider progress, inverse slurp, snap position, min, max value. And then we're going to say slider bar let size is equal to udim2 from scale, slider progress 1, then slider knob dot position is equal to udim2 from scale, slider progress 0.5. And if we were to test this out, oh, this should be a slider fill. Would you look at that? Very nice. Okay. Lastly, we will want to update our percentage and update our music. So I'm gonna have a variable to our music here, workspace.june, and then we're gonna say june.volume is equal to snap position, and then we're gonna say slider percentage dot text is equal to slider progress times 100%. And then we're going to be updating our min and max value to update our music here, because I don't think a max value of 100 for our music is going to be very good. So we're going to say max for 1, an increment of 0.05. So if I were to turn on my volume here, sorry, I was plugging my headphones. So currently music is playing in our background here in our game. If we were to want to decrease it, we'll simply go to our left side, and it's currently muted. We go to our right, and increases. I also forgot to do one thing. We'd want to round this, so it doesn't give that weird decimal places. Now, as you can see, our volume slider is working. As intended. Very nice. That about wraps up for this tutorial. I hope you guys like it. Hopefully I explained some things in this video very clearly. If not, make sure to, I guess, comment down below for some clarification. I will be willing to, you know, explain some things more thoroughly. I feel like I didn't really I don't think I really did a good job on that, but hopefully you guys understood some of the things I've said, some of the solutions I've came up with, and all that. Yeah. Thanks for watching, guys. Thank you. I'll probably see you in the next tutorial or so. See ya!